Assalamualaikum and hi everyone. My name is Siti Nurul Aisyah binti Abdul Aziz from EC1101L. So today my friend and I will explain about differentiation and its subtopic related rates. We will give a question and explain the question, and we also will give the conclusion of our studies today. So keep watching till the end. Basically, differentiation is a method of finding the derivative of a function. The reason why we need to find out the derivation is to determine the maximum and minimum values of the specific functions. Differentiation is a process to find the rate of change in function based on one of its variables. The most common example is the rate change of displacement with respect to time, called velocity. It also allows us to find the rate of change of x with respect to y. If x is a variable and y is another variable, then the rate of change of x with respect to y is given by dy over dx. This is the general expression of derivative of a function and is represented as f prime x equal to dy over dx, where y equal to fx is any function. So, we are moving to differentiation's subtopic known as related rates. What is related rates? Related rates is a problem in which we know the rate of change of one of the quantities and want to find the rate of change of the other quantities. The rate of change is usually with respect to time. Because science and engineering often relate quantities to each other, the methods of related rates have broad applications in these fields. Differentiation with respect to time or one of the other variables requires applications of the chain rule, since most problems involve several variables.
Assalamualaikum, my name is Nur Alihani binti Zamri, and I will show you an example of a question we face regarding related rates. A conical water tank with a vertex down has a radius of 10 meter at the top and is 24 meter high. If the water flows out at the tank at a rate of 20 meter cube per minute, how fast is the depth of the water decreasing when the water is 16 meter deep? How to solve the problem? First of all, we need to list out the information given, which is radius is 10 meter, height is 34 meter, dV over dt is negative 20 meter cube per minute. The negative is inferred from inclusion of the word flows out in the problem. So how do we know dV over dt? We can look at the unit, meter cube per minute. Meter cube is unit of the volume, meanwhile minute is the unit of the time. The question is, what is d hash over dt when hash is 16 meter? In order to find d hash over dt, we have to separate d hash over dt into two parts. We are going to substitute the blank space with the information given, which is dV over dt. But we are only going to use dV. Now we already know the information we need to find d hash over dt, which is d hash over dV and dV over dt. We already know dV over dt is negative 20 meter cube per minute. How about d hash over dV? Now we are going to find d hash over dV first. Let's go. So how to find d hash over dV? First, write down the volume formula of the cone, which is 1/3 pi r squared h. As we can see, there are two variables in the formula, which is r and h. We have to express v in terms of h because dh over dv is needed. Now, in the area, we know r is 10, meanwhile h is 24. Now, we are going to make r in terms of h using ratio. Then, move h into the right side. Now, we got r in terms of h. The next step is, we are going to substitute r we got earlier. Now, we got v is 24/432 pi h cube. Now, we are going to differentiate. Now, we got dv over dh is 25/144 pi h squared. By using the formula, we can substitute all the information that we got to find the value of dh over dt. Next step, dh over dt when h is 16 meter. We have to substitute h with 16 meter. Now we got dh over dt when h is 16 meter is negative 9/20 pi meter per minute. So I can conclude here, the depth of the water is decreasing at the rate of negative 9/20 pi meter per minute when height is 16 meter.
The conclusion that we get from this problem statement is the solution we use to find the value raised are succeed, which is to find how fast is the depth of the water decreasing when the water is 16 meter deep. The rated reads are able to find the derivative of an equation with respect to various variables. We can conclude that rated reads are able to solve various rate of change application. We could also find at which quantity is changing by rating it to another quantity with known rate of change. Last but not least, we can also use these ways to solve another problems that rated in our daily life.
I hope you enjoyed the video, and don't forget to tap on the like button and share to your friends. Thanks for watching.